In this lesson, we're going to look at absolute value expressions and equations. We're going to work our way through absolute value inequalities. Maybe in the next lesson, I want to go over this notion of absolute value using a non-algebraic, more geometric approach. The absolute value of a number has many definitions, one of which is the distance between that number, let's say the number, we call it x, and x is a real number, and 0. Absolute value of x is the distance between x and 0. People know that absolute value makes a number non-negative. And that's true because distance is a non-negative measure. You can't have a distance of -2. That makes no sense. You could say two things are 4 miles apart. Distance is a positive measure. It could also be 0. Absolute value could be 0 or positive. Absolute value of x is the distance between x and 0. Let's look at a couple of examples. Let's say absolute value of 3. It is the distance between the number 3 and 0. I know everybody knows what absolute value of 3 is equal to, but I want to demonstrate this. Think of 0 as the center, as the place where you measure things from. On the number line, we're gonna locate 3. There's 3. Now you're going to measure how far 3 is from 0. If you count the number of units, then absolute value of 3 is 3. So what this is saying is that 3 is 3 units away from 0. The distance between 3 and 0. Now what about absolute value of -3? This can be interpreted as the distance on the number line between -3 and 0. Let's use the same number line, locate -3. Then we're going to count or measure how far -3 is from 0. And once again, we're looking at 3 units. So absolute value of -3 is equal to 3. Since we know the definition of absolute value of x, let's look at an equation. An equation involves equality where you have to solve for an unknown. Let's say the equation is to solve absolute value of x equal to, let's say, 2. So instead of trying to remember any algebraic rules, you're going to think in terms of distance. The distance between what number, or there could be possibly numbers, and 0. That's what absolute value of x is. X here stands for what numbers. The distance between what numbers x and 0 is 2. Again, we can look at the number line and keep in mind that we are measuring from 0. You want to know what numbers are 2 units away from 0. You can go to the right of 0 by 2 units. But I can also go to the left of 0 by 2 units. Therefore, I get 2 solutions. If I go to the right of 0, I get 2, and if I go to the left of 0, I get -2. We get 2 solutions. X equal to -2, or X equal to 2. Let's look at the next example where you have to solve this equation, absolute value of x equal to -1. Let's do the interpretation of this absolute value equation. You ask yourself, the distance between what number, and keep in mind that we are measuring from 0, and 0 is -1. But you're like, wait a minute, how can something have a distance of -1? That sounds impossible. We have a contradiction. Absolute value can never output a negative. Distance can't be negative. So here we say this has no solution since distance is non-negative. It would leave a positive impression on your teacher if you provide an explanation. Now, well, let's look at another definition, and that would be absolute value of x minus c. This is interpreted as the distance between x and c. Remember, if you have absolute value of x by itself, that meant the distance between x and 0, you can think of this as absolute value of x minus 0, which is compatible with this definition. If you want to know how far apart two things are, you subtract their position. For instance, if you want to know how far 5 and 3 are on the number line, you subtract them. You do 5 minus 3, and that gives you 2, meaning that 5 is 2 units away from 3. The distance between 5 and 3 is 2. To ensure that the outcome is non-negative, we use absolute value. A difference calculates how far apart two things are, and absolute value tells you that the outcome should be non-negative. Absolute value of x, where x could be any real number, minus 2. Interpreted as the distance between x and 2. We can see this in action by choosing some values for x. So here we have absolute value of x minus 2. I'm going to choose some values for x. Let's say x here is 4. We get absolute value of 4 minus 2. And that's equal to absolute value of 2, which is really 2. Let's demonstrate this on the number line. Instead of measuring from 0, we're going to measure from, think of the center as 2. That's why I think I call this C for center. So locate 2, let's say 2 is right there. And we have absolute value of 4 minus 2, so you're gonna locate 4. We have 2, 3, 4, and you're going to measure how far apart these two numbers are. they are apart by a distance of 2 units. Let's pick a different number. Let's say we are going to pick -2. Therefore, we're going to get absolute value of -2 minus 2. All I'm doing here is choosing different values for x and holding that 2 fixed. -2 minus 2 is -4, and we all know that absolute value of -4 is actually 4. Let's see if this is consistent with the number line. So again, locate 2. We are measuring x from 2, and this reads as the distance between -2 and 2. So locate -2 on the number line. That would be 1, 0, -1, -2. Okay, and then count how far away these two numbers are. We have a count of 1, 2, 3, 4 units. And that is consistent with the distance between -2 and 2. Absolute value of -2 minus 2. Let's try to solve an equation according to this geometric interpretation. The absolute value without attempting to recall any algebraic rules. This is going to read as the distance between x. X is the unknown. And you can think of the center as 3. The distance between x and 3 is 4. Draw the number line. Begin by locating what I call the center, which would be 3. We are measuring x from 3. We are looking for numbers that are 4 units away from 3. From 3, you just go away by 4 units. You can go to the right by 4. You can go to the left by 4. Let's do that. 1, 2, 3, 4 to the right. That gives you 7 as one of the numbers. We've gone over by 4. And we're going to go to the left by 4. 1, 2, 3, 4. That would be 2, 1, 0, -1. Has been obtained by going back 4 units. So we have our x's. One of them is 7 and the other one is -1. From 3, we added 4 to get to one of the solutions, and we subtracted 4 to get to the other solution. Let's write the solutions out. This is just the easiest way to remember how to solve absolute value equations. I want to finish with one more example, which could be a little bit tricky. Absolute value can't be negative. Notice that inside the absolute value, we have x plus 5. And you can't directly interpret that as a distance. What you need to do first is to rewrite this so it is consistent with the definition. We could think of this as the absolute value of x minus positive 5 is negative of negative 5. Interpretation of this is the distance between x, which is your unknown, and not 5 but negative 5 is 6. Whenever you see absolute value of the sum of two numbers, you can write that positive as a double negative, so you can identify your C. X minus, that's your C, negative 5. So now let's rely on our number line. Here the center is negative 5. We are measuring things from negative 5. Let's say negative 5 is here. You don't need to draw a full number line. Let's say put 0 there and then negative 5 here. I can just put negative 5 in the center of my number line. The location of negative 5 is on the number line is not relevant really. We want a number x that is 6 steps away from negative 5. Go away by 6 steps from this center. 1, 2, 3, 4, 5, 6. Let's see what we get. That's negative 4, negative 3, negative 2, negative 1, 0, 1. What we have done is we've really added a 6 to negative 5. We've gone over by 6 units. So you can think of this number, which is where we end up with, as negative 5 plus 6. Negative 5 add 6. So we've arrived to one of the solutions, 1. And I can go to the left of negative 5 by 6 units. You can take negative 5 and since you're going back, subtract. But instead of doing that, let's just locate the numbers and see where we arrive. We have negative 6, negative 7, negative 8, negative 9, negative 10, negative 11. That is the other solution. So how do we get to this negative 11? By counting, we can take our center of negative 5 and go back by a distance of 6. Since the distance is 6, from the center of negative 5, we go over by 6, negative 5 plus 6, or you go under by 6, negative 5 minus 6, and we have our solutions. X equal to negative 11 or x equal to 1. And you can always check to see if your solutions are correct. If you put 1 inside the equation, you have 1 plus 5, that's 6. Absolute value of 6 is 6. Negative 11 plugged in for x. You get negative 11 plus 5, that's negative 6. And absolute value of negative 6 is in fact 6.